Hello and welcome. The purpose of this video is to go through how to balance a reaction. So what I'd like to start with is why we actually need to balance a reaction. Let's take a look at an example reaction here. This is the decomposition of hydrogen peroxide, or H2O2. And let's see what this reaction actually looks like. So I have one molecule of H2O2 that's going to look something like this. Two oxygen atoms and two hydrogen atoms all covalently bound to make one molecule of H2O2 is going to yield H2O plus oxygen. All right, so if I take a look at my reaction, I see I have two hydrogen atoms in my reactants, and those form two hydrogen atoms in my products. However, I see with oxygen, I have two oxygen atoms in my reactants, and one, two, three oxygen atoms in my products. Well, what's the problem with that? We've learned in class that mass is always conserved. We've also learned in class that a reaction, a chemical reaction or chemical change, is simply a rearrangement of atoms with new chemical bonds. So that means that a reaction cannot create new atoms. If I start with a certain number of oxygen atoms, I need to end with the same number. And right now, that's not what I'm showing. So when the atom counts, when the atoms of one element are different in the reactants and in the products, that tells me I need to balance my reaction. All right, so let's look at how we might do that. Again, I'm going to write my reaction. H2O2 yields H2O plus O2. And let me just leave a space. Okay. So the first thing that I'm going to do whenever I balance a chemical reaction is I'm going to find the reaction arrow and I'm going to draw a line down the middle. This helps me separate out my reactants from my products. And I know the atoms in my reactants need to equal the atoms in my products. My next step is what's called an atom inventory. So I'm going to count up the atoms that I already have. Hydrogen, oxygen. I'm going to put my atom inventory in the same order in my reactants and in my products. That's important because now I'm going to be able to compare directly across between my reactants and my products. So if I start with hydrogen, I need to have hydrogen first on the other side. I know when I have a new element, when there's a new capital letter. So if H and then oxygen is also capital, that tells me I have a new element. All right, so in this molecule H2O2, I have two hydrogen atoms and two oxygen atoms. Now in my products, I have two different molecules to consider. In all of the products put together, I have two hydrogen atoms, but I have three oxygen atoms. All right, so my next step is to start balancing. And the only way that I can balance a reaction is by changing coefficients. Coefficients tell me the number of molecules present in the reaction, not individual atoms, but entire molecules. All right, so generally I want to start balancing with something that's not hydrogen or oxygen. Start with any element other than hydrogen or oxygen. But in this case, hydrogen and oxygen are the only elements I have, So I'm going to start with the one that's not balanced. I see oxygen is not balanced, and this should be, I'm so sorry, this should be a 2, not a 0. So I see oxygen is not balanced, and I see that I need more oxygen atoms on the left. Well, the only way I have to add more atoms is to add an entirely new molecule. I'm not allowed to just add a single atom. I need to add a new molecule, and now I have 2 H2O2s in total. Once I've added a coefficient, I then update my atom inventory. I now have 1, 2, 3, 4 hydrogen atoms and 1, 2, 3, 4 oxygen atoms. All right, I now go to my products and I see my products are no longer balanced with my reactants. I'm going to need more of both hydrogen and oxygen. I take a look at the 2 product molecules and I notice that water has both hydrogen and oxygen. So I'm going to try adding another water molecule. All right, now that I have 2 water molecules, I've changed a coefficient. So my next step is update the atom inventory. All right, now with 2 water molecules, how many hydrogen atoms do I have? Let's see. 1, 2, 3, and 4. So we're going to update this to 4. And how many oxygen atoms do I have in total in my products? 1, 2, 3, 4. So I'm going to update this to 4. I now have 4 atoms of hydrogen on the left and on the right, 4 atoms of oxygen on the left and on the right, and so I am indeed balanced. So just to review, what was my first step? Draw a line to separate my reactants and my products. That helps me see what's on the left of the arrow, what's on the right of the arrow. So this line is really important. I then do my initial atom inventory. I then decide an element to start balancing, not hydrogen or oxygen unless it's my only choice. I update a coefficient wherever I need more of a certain type of atom. I choose the molecule that will give me more of a certain type of atom. And then immediately, as soon as I've updated my coefficient, I update my atom inventory. I continue this process of updating coefficients, updating atom inventory until all elements are balanced. Continue until all atoms of each element are balanced in the reactants and products. One thing to note, in this example, we happen to have 4 hydrogens and 4 oxygen atoms. That was just a coincidence. What we need is if I have 4 atoms of hydrogen, I will end with 4 atoms of hydrogen. If I start with 4 atoms of oxygen, I'll end with 4 atoms of oxygen. These two do not necessarily need to be equal to each other. All right, I hope that was helpful. Let your teacher know what questions you have. Thanks for watching.